Greetings, my little triglets. Welcome to the last set of notes that you will take for trigonometry this year. All right, section 5.5. We're going to talk about the area of a triangle. Now you know it as 1/2 base times height. That's what you've learned in the past. However, what if you don't know some of that information? Let's do a triangle here where we're not quite sure. And I'm going to drop an altitude here. It's a right angle. And I want you to look at 1/2 b, which is the base, and then times the height. Now, if I'm looking at angle A, this height, I could say the sine of A is equal to opposite h over hypotenuse c. So if I isolate the h, move the c over here, I get c sine A for the height. So base times height here would be c sine A. So we have a new formula. It's still base times height, but our height is given in terms of a trig expression. So this is just a new formula. And depending on which angle you're given, it might be 1/2 BC sine A, or it might be 1/2 AB sine C, or it might be 1/2 AC sine B. But you'll notice A, B, and C are represented in each part. So A, B, C, A, C, B, they're all have the A, B, and C involved somehow. And you have two sides and an angle. And you could say it's used in side angle side triangles. All right, so let's try one of these. It's fairly straightforward. Let's say I have angle R is 112.9, side P is 87.4, side Q is 76.1, and I want to find the area to the nearest tenth. So R, P, and Q, let's make sure we have side angle side, so we have 112.9. Side P is down here, 87.4, and side Q is 76.1. So we have side angle side. So we just plug it in. 1/2 side times side, 87.4, 76.1, and then the sine of the angle you have, which is 112.9. Work all that out, you should get about 3,063.5, and then inches squared or whatever the units are. Okay, so pretty straightforward. It's just the two sides are your A and B, and then sine C, that would be the angle. Now, that's for side angle side. What if you know side, side, side? You need all three. Well, and you want to find the area, you could use the law of cosines to find one angle and then use the 1/2 AB sine C formula. Or there's another way, because using the law of cosine sometimes can be kind of cumbersome. Another way is to use some guy, his name was Mr. Heron. We'll use Heron's formula. And he figured out this formula. I'm going to write it first, then I'll explain what it is. They use K instead of A for area. I'm not really sure why. I'm thinking it has something to do with Kendro, but I can't be sure, so I better not say it 100%. But the formula goes like this. S minus A, S minus B, S minus C. Now, what's your first question? Very good. What is S? S represents the semi-perimeter. Semi means half, so if I want to find the perimeter of the triangle, I add up the sides, but I cut it in half. So that's what S is. Okay, so let's do a problem that involves Heron's formula. Let's try it. Let's say we have a triangular sign and the sides are 11, 13, and 16, and it needs a brace from an angle to the longest side, and I want it to be the height, so I need to make it a right angle, so I need that brace. There's our height. So I want to find the height. Well, we have side, 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 so that means I'm going to use Heron's formula to find the area. But then our area formula, that doesn't give us the height, but we do have an area formula as 1/2 base times height. If I can use 16 as my base, and then I can figure out the height from Heron's formula, then we can figure this out. All right, so let's do this. First, well, let's find the semi-perimeter. That's 11 plus 13 plus 16 divided by 2. So that's 40 divided by 2 would be 20. So the area of the formula, or K, whichever one you want to use, would be 20 minus 11. Oops, I need a 20 at the beginning. So 20, then 20 minus 11, 20 minus 13, and then 20 minus 16. Okay, do all that. So square root of 20 times 9 times 7 times 4, and I got an answer of 71. So that is the area of the triangle. So if I set that equal to 71, and I'm solving for height here, 71 equals 8 times height. So divide both sides by 8. So I get the height to be about 8.9. Okay. So you had to know a couple of things. You had to know Heron's to find the area, and then we had needed the area formula to be able to solve for h. Okay, I've got one more problem to show you, and a little reminder before I show it to you. Area of a sector we've talked about, and it's pi r squared theta over 360 when you're using degrees. Let's say I want to find the area of a segment, not sector, but a segment that has the center angle Q, we'll call is 80 degrees, and the line QR is 10 feet. So here's my circle. I've got a center angle. This is 80. We'll call this Q and R. This is 10. Now I want to find the area of the segment. Segment is this part right here. It's like the crust of the pizza. So our plan of action is to take the area of the sector, which is this little ice cream cone thing, and we want to subtract the area of the triangle, and that will leave us the area of the sector that we're trying to find. So that's our plan of action. So area of a sector, it is pi 10 squared, because that's our radius. The angle is 80 over 360. Now the area of the triangle, we aren't given very much. It's not a 30, 60, 90. We can't do any of those things, but we do have side angle side. So I can do 1/2 AB sine C formula. So 1/2 10, 10 sine of 80. So we'll put that in right here. 1/2 10, 10 sine of 80. So working those out, I get 69.2 here and 49.2 for this one. Oops, 69.8. So I got a total of 20.6 feet squared for the area of the segment. So you just have to have a plan of action. Drawing it out real simply like I did here might help figure that out, and then just use the formulas to do all the work for you. All right, people, that is it. I hope you enjoyed the videos somewhat. And don't forget, Trig loves you, so you need to love Trig right back. Ta-ta.